Alright, so in this video we go over section 2.3, in which we are going to do a brief review of all about the equations of lines. So we're going to go over how to calculate and interpret the slope, what it is, how to use it, and then graphing lines given different pieces of information, find equations of vertical and horizontal lines, and graph equations from intercepts and get their equations, and find equations of parallel and perpendicular lines. First of all, this box right here summarizes pretty much everything about lines. The number one piece of information is the slope, which is the ratio to the rise, the ratio of the rise to the run. The point slope form of an equation of a line, we use this form when we know the value of the slope and a point. The slope intercept form of an equation of a line is the famous y equals mx plus b, in which m is the ratio of the rise to the run again, and b is the value of the value in which the line crosses the y-axis. Equations of vertical and horizontal lines. One thing to differentiate here is vertical lines are x equals some number, as opposed to horizontal lines, which are y equals some number. One very important piece of information here to keep in mind as well: the slope of a vertical line is undefined, as opposed to the slope of a horizontal line, which is 0. Another one form for the equation of a line, it's what we call the standard form or general form. By the way, there's a little typo here. This one is supposed to be an equal sign, and this is supposed to be an uppercase C. And this equation is obtained when we get all the variable terms to the left hand side and the constant term to the right hand side. Lastly, we need to consider the criteria for parallel lines. Parallel lines are lines that have the exact same slope, the same steepness, however they have a different y-intercept. The criteria for perpendicular lines: the slopes have opposite in sign and they are reciprocal to one another. So we are going to do one example of each in the next page. So let's see. Find the slope of the line containing the points 4, 2 and negative 5, 2. So it would be great to label these numbers. This is our x1, y1, and x2, y2, just the same way we did it in the previous section, just so we can differentiate what this is. So the slope m, which is y2 minus y1 over x2 minus x1, y2, which is 2, minus y1, which is also 2. Well, actually, let me change the number. Let me make it at 3. Otherwise, it's not going to be very interesting. So I'm going to be changing that for 2 minus 3, which is, and then we divide by x2, which is negative 5, minus 4. So 2 minus 3 is negative 1 divided by negative 5 minus 9. That is negative 9. And if we simplify this to we can just cancel the negative signs, we get 1/9. So this means that this line will rise 1 unit, go up 1 unit, and then run 9 units. Okay. So now let's get into graphing. Graph the line that contains the point P equals 1 comma 3 and has a slope m equals negative 2/3. Here we are going to do a better interpretation of what the slope is. First of all, I'm going to plot the point 1 comma 3, and then from there we are going to draw the line using the value of the slope. Okay, so every time we have a negative slope, like in this case, we can do the following. M equals, and when the negative is in the front, two ways we can interpret this in two different ways. Either the negative is in the numerator or the negative is in the denominator, and visualizing these two ways is going to help us when it comes to drawing the graph of the line. So this means we are going to go down or dive to units, run 3 units. Otherwise, if we interpret it this way, we can rise 2 units and not run. Actually, I would say go back or reverse. Actually, go back, reverse 3 units. So let us interpret the first way. So dive to units, that's from here, go down to units and run 3 and plot the point. Go back to the given point 1 comma 3. Now do the process of rising 2 units and going back 3 units, and then from there just draw the line, and that's the line that has this point and this slope. Alright, we have another example in which we are given the slope of negative 2 at the point 4 comma negative 3. So in this case we are going to use the point slope form, which is y minus y1 equals m times x minus x1. In this case, y minus y1, which is the negative 3, this is our y1 and this is our x1. So negative 3 equals m, which is negative 2, times x minus 4. Okay, so using the SMILE rule here, we can turn this into a plus. Y plus 3 equals negative 2x, negative times a negative equals positive 8. And in this case, all we do is solve for y. To get that done, all we need to do is subtract 3 from both sides, which will give us y equals negative 2x plus 5. Final answer here. Okay. Alright, find an equation containing the points negative 1, 1 and 2, 2. So in this case, we don't know the slope. However, we have enough information here to get the equation, because we can use these 2 points to get the slope, and then from there we are going to find the equation of the line. So m equals y2 minus y1 equals x2 minus x1. So y2 minus y1, this will be 2 minus 1 divided by 2 minus negative 1. So in this case, this will be positive 2 minus 1, which is 1, and 2, this is really a plus. 2 plus 1 will be 3. So we are going to have the slope of 3, and then from there use the slope and any of the points to find the equation of the line. I'm going to use the second one because the second one doesn't use any negatives, okay, so we don't get like a lot of silly mistakes with negative signs. So I'm going to use the same form as in the previous exercise. Y minus y1 equals m times x minus x1, in which y minus 2 equals m, which is 1/3, times x minus x1, which is also 2. Okay, so I'm going to distribute this 1/3, so y minus 2 equals 1/3, x minus 2/3, 2/3. So the only thing we need to do now is add 2 to both sides. Okay, so when we add 2 to both sides, 2 times 3, that's a 6, minus 2, that's going to be 4/3. Okay. And that's final answer. Alright, so let's see what do we have in the next page. In the next page we're going to look at vertical lines and horizontal lines. Okay, so in this case we are going to have basically 2 questions in the same one in this example. So in this case, let's find the equation of the lines given the conditions and graph them. Alright, the number one piece of information is the equation we want. Well, the equation we want is slope undefined and contains the point 3, 4. Okay, so let's plot the point 3, 4 right here, and the slope is undefined. So what do we know about the slope being undefined? Would that be for horizontal lines or vertical lines? Alright, so if you answer vertical lines, well, that is correct. So I'm going to draw a vertical line, and the value of x that you can see is x equals 3. So that's the equation of this line. For part B of this exercise, we want the slope equals 0, for which that's going to give rise to a horizontal line containing the point 2, 1. So let me use a different color. Well, I'm going to use a different color. 2, 1, and in this case I'm going to do a horizontal line. So this one is y equals to 1, and this one vertical line will be x equals to 3. Okay, now let's do a couple more one that has to do with parallel lines. So let's see, find the equation of the line containing the point 3, 2 and parallel to the line. Alright, again, keep in mind that in order to get the equation of the line, there are 2 pieces of information that we need to have. Number 1, the one piece of information that we need is the slope. The other one is at any point. In this case, we are given a point. However, the piece of information that we're missing apparently is the slope. However, in this case, the key is that we want a line that is parallel to another line. So this is what we are going to do. First of all, I'm going to solve this equation for y to subtract. So I'm going to subtract 2x on both sides, so negative y equals negative 2x plus 2, and then I'm going to divide by negative 1 to get y by itself. From here, this is what we are going to get. This number that multiplies the variable x, that is the slope. So in this case, we want to get the equation of a line containing the point 3, 2, okay, contains the point 3, 2, and has a slope of 2. In other words, this is the same as saying 2 over 1. That is, rise to units, run 1 unit, rise to units, run 1 unit, or go down 1, back 1, down, back, etc. So in this case, that's the graph of the line that we want to obtain. Okay, we were given the line -2 okay, so notice how these two lines are parallel. This green line will correspond to y equals to 2x minus 2. Whilst this line, well, we are going to find out what that is. We're going to use the slope and the given point, y minus y1 equals m times x minus x1, in which y minus 2 equals 2 times x minus 3. So this will be 2x minus 6, y minus 2. All we do to get this equation, add to the both sides. And in this case, notice the y-intercept. 2x minus 4. Y equals 2x minus 4. Notice this equation is parallel to the given one. Y equals 2x minus 2. How do we know they are parallel? Well, from the picture, but also because these two lines have the exact same slope. Okay, the slope is 2, the slope is 2. That's how we know two lines are parallel. Okay, let's do another example. Find the equation of the line containing the point 1, negative 2, but perpendicular, not parallel this time, but perpendicular to the line y equals to x minus 3. So it would be a good idea to review the concept of, or rather the criteria for perpendicular lines. So for perpendicular lines, we need to make sure that we get the slope for the given line and then do two things to it. Number one, change the sign and find its reciprocal. So in this case, from the highlight here, m equals 2, okay, which is the same as saying m equals 2 divided by 1. The reason why I'm writing this invisible 1, it's because I'm going to find the slope of the perpendicular line. This symbol, this fancy symbol that looks like an upside down uppercase T, means perp. Okay, this means perp because this is to denote that this is the slope of the perpendicular line. So what do we do with the slope of the perpendicular line? Number one, change the sign and find the reciprocal. So the reciprocal of 2 over 1 is 1/2, and the opposite sign is, in this case, it's positive. We change it to negative. So now that we have the information here, well, first of all, it would be a good idea to draw this line. So the y-intercept, it's at -3, and the slope, which is 2, rise to units, run 1 unit, rise 2, run 1, rise 2, run 1, rise 2, run 1, go back, go down 1, go back 1, go down 1, go back 1. Okay. Oops. So that's going to be our line here. Okay. And we're going to use y minus y1 equals m times x minus x1, in which y minus y1, which is negative 2, equals m, which is negative 1/2, times x minus 1. Should have used orange here. Okay. So this will be turned into a plus. And then distributing the negative 1/2, we get negative 1/2 x, and then negative times a negative, that's positive 1/2. Finally, what we do is subtract 2 to both sides. Okay, subtract 2 to both sides in order to get y equals negative 1/2 x, and 1/2 minus 2, if you want to use a graphing calculator to do that calculation. Well, let's see, 1/2 minus 2, enter, you're gonna get a decimal. Let's frac it. Negative 3/2, which in this case I'm gonna use the negative 1.5, which is right here. So let me highlight this with pink, and I'm going to use that same color for the perpendicular line. I'm going to go to negative 3/2, which is negative 1.5, and then from there I'm going to go 1 unit down and run 2 units. Go 1 down, run 2 units. Go 1 down, run 2 units. I'm going to rise 1 unit, go back 2, rise 1 unit, go back 2. And in this case, this is what we get. So from the picture, clearly these two lines are perpendicular because they form a 90-degree angle at the intersection point at any of the sides. So let's label, this is y equals negative 1/2 x minus 3/2, and the pink one will be the given one, y equals 2x minus 3. Alright, let's do one more example regarding equations of lines, and that's another very classical problem. Graph the equation of the line by finding its intercept. So not by drawing a table of values or by solving for y and then do the rise over run, but rather by finding the intercept, which is what we learned in the previous section. Okay, so let's find the x-intercept. Keep in mind, recall that in order to get the x-intercept, you let y equal to 0. So, and solve for x. So 2x plus 4 times 0 equals 8. So 4 times 0 is going to be 0. 2x plus 0, this is going to be 2x equals to 8. And then divide both sides by 2 to get x equals to 4. So that's the solution, that's not the intercept. So the x-intercept will be 4, 0. Let's plot that point, 4, 0. To get the y-intercept, we do the opposite. Let x equals to 0. So 2 times 0 plus 4y equals to 8. So this is going to be 0 plus 4y, which is simply 4y equals to 8. And then we divide both sides by 4 to get y equal to 2. So the y-intercept here will be 0, which is x, and because of this, and y equals to 2. So we have those 2 points, and we just connect them using a straight line. Alright, and this is the end of this section. It's a brief review of all about equations of line, all the different properties and different cases, like those special cases in which we look at vertical lines, horizontal lines, and one of the most important ones, which are parallel lines and perpendicular lines. I'll see you on the next video.